Section 9.2 ellipses. These are the objectives. Write equations of ellipses in standard form. Use properties of ellipses to model and solve real-life problems. Most of this section is going to be familiar. These are the concepts you saw in Algebra 2. We're going to review them. Now we're going to be applying this to word problems. Let's move on to but not until the end of this video. Let's move on to the next slide. This is the standard equation of an ellipse. This is representing an ellipse in which the major axis is horizontal, center at HK. How do I know it's horizontal? Because the A is greater than the B, and notice that the A is below the X variable. In the same manner, this is an ellipse in which the major axis is vertical, center at HK. How do I know it's vertical? Because the A is greater than the B, and the A is below the Y variable. And you remember this, c squared equals a squared minus b squared, where c is the distance from the center to a focus. Something you saw in Algebra 2, we're seeing it again. Additional properties that you learned in Algebra 2 of ellipses. Any point along the ellipse, this happens, d1 plus d2 is always the same number. And then we have vertices, co-vertices, major axis, and the minor axis. Let's move on to the next slide. Excuse me, here's number 1. It says find the center, vertices, and foci of the ellipse and sketch its graph. So this is what you have. Notice that in this case, is center at 0, 0. And from here, you know that the A is 9. And notice that the major axis is vertical, and the B is equal to 4. So that's why the vertices are 0 plus or minus 9, which you're going to see them right here. So here are your vertices, and these are your co-vertices. And again, how do we get these numbers? From the center, you're going to travel 9 up, down, 9 down, and from the center to come up with the co-vertices, 4 to the right and 4 to the left. And then at this point, we're going to go ahead and find this the foci. So I need to take the square root of this difference. Use to see where I get the 81 and the 16 from. And then I subtract, I get 65, which is approximately 8. And in a little bit, I'm actually going to approximate this point on the graph. And the square root of 65 is approximately 8. I did a little bit more than 8. So once I go to my graph and plot the foci, this is for you, my find those 2 points. And again, this is an approximation. I'm not going to go ahead and draw the ellipse. You go for it. It's just a little bit challenging with that bamboo. Let's move on to the next slide. Here's number 2, same directions. So let's go ahead and first find the center, which is right there, -3, 2. I go ahead and graph it. Then at this point, I'm actually going to use the A and the B to find the vertices and co-vertices. Notice that the A is 4 and the B is about 2.8. And this is the major axis is vertical. So from here, from this point, I'm actually going to travel 4 units up, 4 units down, 2.8 to the right, 2.8 to the left, and that's why I end up with those points. From here, I'm going to find the foci. Excuse me, I'm going to, so I know that these are my vertices, -3, 2, and -3, 6. And then I'm going to find the foci. I go through the math, plug in the values into this formula, and I end up with 2 radical 2, which is approximately 2.8. So from here, I'm going to travel 2.8 up, 2.8 down, and this is how I get the coordinate values of the foci. So all I'm doing, I'm from here I go up 2 units to the y value 2. I add 2 radical 2, and also to the y value of 2 I take away 2 radical 2. So that's why I come up with these coordinate values for the foci, and then once I graph them, this is what I get. Let's go to the next slide. Here's number 3. There's 3 parts. First, let's find the standard form of the equation. So what I'm doing is I'm pairing up the variables right next to each other. Move the 2 to the -2 to the right hand side. Then I'm going to be completing the square, and I want to maintain equality, so I need to, whatever I do to one side, I need to add it to the other side. So let me get a pen here. So I'm adding 9 here, and I'm adding 25 over 4, but not really 25 over 4. It's actually 4 times whatever this is, and that's why you see only 25 here. The 9 is this 9. Then I factor this and get the following. Since I want an ellipse, I want to divide everything by 36, and this is the equation of the ellipse. Now that I have this, let me bring it over here. Need more space, so then I can find the center. So now let's go to this is part 2 of the problem. So here's the center. At this point, I'm going to graph the center. I can find the A, the B, and also the C. And this is what I get. Now from here, I'm going to travel to find the vertices. 6 to the right and to the left, 3 up and down, and I end up with those points. I give the coordinate value of the vertices, and you should follow that is the following. And then at this point, I'm going to find the foci. So to find the foci, I'm going to travel 5 units to the right. So to the x value, I'm going to add 5.2 units, and I'm going to take away 5.2 units to the x value to get the other focus. And once I do that, this is the coordinate value that I get. Notice that I'm not doing anything to the y value. The y value is the same, -5/2. Now finally, once we have the foci, all we need to do is just graph it in the coordinate plane, and this is a good approximation. And again, I'm not connecting the points, but you can do that. Let's move on to number 4. Set directions. So I'm going to go through the steps to put this in standard form. Notice that I'm pairing up the variables, and not only that, I'm pulling the common factor that I see between the x's and the y's. And I have 9 and 25. Move the 61 over, it becomes -61. I complete the square, so I add 4, get a pen, I add 1, but not really 4, I'm actually adding 36 and I'm adding 25. So then I bring those numbers to the right hand side, continue. Notice that I get 0 on the right hand side. We'll worry about that in a second. So now what I'm going to do is I want to get rid of the 9 and the 25. So I actually divide everything by 225. Once I do that, I get the following. So I'm done with part 1. Part 2 is the center is to 1. Can I find the vertices, foci, and ellipse? The answer is no. So I'm going to just go ahead and graph the center. And to sketch the ellipse, I'm basically done. Why? Because this is what we call a degenerate ellipse with center at 2, 1. Let's move on to the next slide. It says find the standard form of the ellipse with the given correct characteristics and center at the origin. So you're given the vertices and the foci. You don't have to do this. I mean, you don't have to graph it, but it's going to help us see this better. So the vertices are 0 plus or minus 8. So I can go ahead and graph them. And I notice that my major axis is vertical. They don't give me the coordinate value of the co-vertices, so that's what I need to find. And I'm going to be doing the following. So I know that A is 8, and I'm looking for my B squared. So this is what I'm going to do. I also know that C is equal to 4. They gave me that. So then I'm going to use this formula. I solve for B squared in the formula, and this is what I get. I substitute my A and my C, square them, and I get 48. So now that I know my B squared, I'm basically done. The equation of the ellipse in standard form is the following. Let's move on to number 6. Different same directions, different information. Foci plus or minus 2, major axis of length 12. So I'm going to use the coordinate plane. So here's my, since the major axis is 12 and the center is at the origin, I travel 6 to the right, 6 to the left. So that gives me my A. The fact that the major axis is 12, I know that A is equal to 6. From here, I also know my C, which I'm going to use that in just a second. But basically, I'm looking for my B. So I want to know how far we need to travel to come up with my co-vertices. Since, like I said, we were given the C, so I'm going to plug it in into this expression here. B squared equals A squared minus C squared. You should see where I get this from. I can clarify it. If you don't see it, just talk to me in class. So I end up with 32. Once I have 32, I'm basically done. I substitute it in here, and this is my answer. Let's move on to number 7. So here's number 7. Different directions. Says find the standard form of the ellipse with the given characteristics. Notice that we're no longer at the origins. They give you the center, some information about A and C, and also where the foci can be found on the graph. So I'll go ahead and come up with a coordinate plane, graph the center. I'm also going to, in a little bit, I'm going to be using this information. I'm going to graph the foci. And notice that the distance from the center to the one of the focus is 3. So that means that my C is equal to 3. So now I can find A. A is going to be equal to 9. So now I need to do is find my B squared. How am I going to find my B squared? Using this formula, and I end up with 72. At this point, all I need to do is substitute the information into my standard form of the ellipse, and this is my answer. Let's move on to the last problem, number 8, which is a word problem. Follow along. This is a semi-elliptical arc through a railroad underpass has a major axis of 32 feet and a height of at the center of 12 feet. Draw a sketch of the underpass with the center of the road entering the underpass at the origin. Identify the coordinates of the known points. So let me give you the sketch. So this is the coordinate value of 0, 16, excuse me, 16, 0, negative 16, 0. This is 0, 12. So we're done with part A. Part B says find the equation of the semi-elliptical arc over the underpass. So all I need to do is recognize that my A is 16 and my B is 12 and the center is at the origin. So this is what I get. Why do I have this? Y greater than or equal to 0? Because we have the ellipse above the y-axis. I mean above or equal to about the y-axis. So then let's go to part C. It says, will a truck that is 10 feet wide and 9 feet tall be able to drive through the underpass without crossing the center line. So here's your center line, and here's a truck that is 10 feet wide. Let me just kind of approximate. And 9 feet tall. We want to be able to see if it will clear this underpass. So what are we going to do? We're actually going to use the equation of the this ellipse, semi-elliptical shape, and then plug in the x value and find out what we get for y value. So once I do that, I substitute x equals 10 in here. I'm going to do a little bit of algebra. I get y is equal to this. At this point, I simplify this a little bit further. I end up with the following. And then at this point, I end up with 351 over 4, and then I need to take the square root of that. Once I do that, I end up with 9.37. So the x value of 10 produces a y value of 9.3. The truck is actually 9 feet tall, which means that yes, the truck will be able to drive through the underpass without crossing the center line. This concludes the video 9.2.